Hello and welcome. In today's class, we'll be discussing the linear search algorithm. This is a part of ICSE computer application syllabus. So, what is a linear search? Linear search is a simple search algorithm. It sequentially checks each element of the list until a match is found or the entire list has been traversed. Let's try to understand this with an example. Consider this array with 5 integers 95, 47, 125, 18 and 72. And let's say we want to search whether 18 is there in the array or not. So 18 is our key element. So if we apply linear search to search for 18, then the searching will begin from index 0. At index 0, we find 95. So 18 is unavailable here. Each time when we realize that the element is unavailable, the index counter increases by 1. So because at index 0, we have not found the element, the index counter increases to 1. At 1, again we search for 18, but instead we got 47. So again, we could not find it. So the index counter will once again increase and it will become 2. At 2, we got 125, still not 18. So once again the index counter increases. And finally at index 3, we found 18. So this is an example where the key was found. But what if the element that we are looking for is not there in the array? Then how linear search is going to behave? So let's take another example. Again, we have the same array, but this time we are looking for 50. So again, the searching starts from index 0. Because we didn't find 50 here, as I've told you, each time we don't find an element, the index counter has to increase by 1. So now index becomes 1. At index 1, we got 47. Again, we did not find 50. So again, it's going to increase by 1. So it becomes 2. At index 2, we got 125, still not 50. So again, the index is going to increase. So it becomes 3. At index 3, we have 18. Again, not 50. So again, the index is going to increase. And now the index becomes 4. At 4, we got 72. And we still didn't find 50. And because we still didn't find 50, now from 4, the value of the index counter should increase to 5. Because as I've told in the beginning, each time we don't find the element at a particular index, the index counter increases by 1. So at the end, when index was 4, and at 4 also it didn't find, so finally the index will be 5. And 5 is equal to the length of the array. If you see, the length of the array is also 5. So if the index counter becomes equal to the length of the array, this indicates that the element that you are looking for is not present. So this condition can be used to check whether the element was found or not. If the index counter is equal to the length of the array, then the element was not found. So that's the concept of linear search. Let's write a program to implement it. So here I've created a file linearsearch.java. We start with the import statement. Then we create the class linear search. Inside, we include the main function and we create the scanner object. Let's create an array of integer data type with 5 elements. So 92, 34, 80, 12, 72. So we have 5 elements. And now let's ask the user to enter the element to be searched. And this is going to be our key element that the user enters. Now we need an index counter. So we take I as the index counter and set it to 0. And while I is less than the length of the array, because if it becomes equal to the length of the array, this will indicate that the element is not available, the element that we are searching for. So as long as it is less than the length, we keep checking. So if the ith element is equal to the key element, we call the break keyword to exit from the loop, because we have found what we were looking for. So we stop this loop. Otherwise, I++. And outside the loop, first of all, we check that during the loop, if I has become equal to the length of the array, that means key was not found. Else, key found at position I+1. Why I+1? Because the user will not take the first element as 0. The user will take the first element as position 1, not as position 0. That's why we are adding 1 to the index I when we are displaying it for the user. So our program is complete. Let's check the output. So if we search for 12, so 12 was found at position 4. So if you look back at the program, yes, it is present at position 4. Actually, it was present at index 3, but because we added 1 to it, so it is now showing position 4, so that the user can understand. Let's try another example, and this time if we give, let's say 100 and press enter, then 100 not found. So that's all in this class. I hope you have understood the concept of linear search, and you have also learned how to write a Java program to implement linear search algorithm. Thank you for watching, and see you soon in the next class.